Afternoon, everyone. Here we go. And hopefully you've managed to get yourselves over quickly. I know it's fast and furious, but we're trying to get as much content in as we can. I'm very pleased that we have Chris Jones from Frazer-Nash to join us. Chris is group leader of the Asset Integrity and Digital Systems Group in Frazer-Nash, locally here in Middlesbrough. So we have gone from Genoa to Middlesbrough, but anyway, it's all virtual anyway. But he's got a really strong background in this area. We've all heard people talk about digital twins and the like, but again, I think it's always useful to bring some reality to all of this stuff. I know we're on a virtual event, but it is important to bring it back and practical examples. And I'm sure that Chris will be very, very good at leading us through the journey here. So you're okay to present, Chris. I'll disappear off, and hopefully your presentation will come up shortly, and I'll see you at the end. Thank you. Yeah.
Okay, thanks everyone. So my name's Chris from Frazer-Nash. Just before I disappear behind the slide deck, I'll say hello. I'm going to talk today about the future trajectory of digital assets, some stuff that's going on now and some stuff that we think is coming in the future. And there's a fair number of videos embedded in today, so I'm hoping that technology supports the video sharing, but we will see. So I will send my slides live and say goodbye to you in person for a few moments. And let's hope the technology works. So all being well, everyone can see my slides now. I'm Chris from the group. I'm the group leader in the Northeast office, as Felix described there. I look after our work there in the process rail and other industries as well. And what I'm going to talk to you today about is the process plant of the future. So we can do things now, things exist now, and we're doing things now with assets, digital assets, machine learning, but what does it all mean, and how is it all going to come together, both now, and how is it coming together, and how is it going to come together in 5-10 years' time? So today's presentation is based on things that exist today, things that are being done in other industry, and I'm going to try and provide a process sector perspective on some of that. But some of this is just about taking technology that exists and putting it together in the right, safe way. So how do we stitch things together that we have now and make that work to best effect? And what I'm going to try and outline in slides and videos that follow is how does all this come together? What does the process look like for asset management? How does cost come into it? And crucially, how do we realize those cost and time savings? So before we duck into the process sector, I want to kind of, through today's presentation, tell a tale of the automotive industry, because there's an awful lot we can learn and there's some nice lessons we can take from what's happened there. So Frazer-Nash's heritage goes back to a man called Archie Frazer-Nash in the 1920s, who was building cars. And his cars had no automation. And what we can see on the right here is a nice scale that's used these days to define automation in the automotive industry. Way back when Archie was building cars in the 1920s that, as you'd expect, had nothing at all, were absolutely awful to drive, but nevertheless were doing the job they were there to do. What we have these days, 100 years later, is Tesla and other cars driving about the place using machine learning technologies to look after the car, do the things and operate the car in the way that it needs to operate, and doing that in a safe way. And that's kind of sitting around this level 4 point of highly automated systems. They can't quite yet navigate in complete snow and whiteout conditions and all the rest of it. So they're not what we call fully autonomous, but they've been on that journey, and automotive has got there. They've realized the end results of going through real-time online asset use and management. So where's the process sector sit relative to that? Where do we think chemical plants sit within that scale? Well, I think fundamentally they sit somewhere between 1 and 3. There's elements there that are conditional based, safety systems, venting systems that will be doing things automatically in the interests of safety. But there's an awful lot of human based input to that as well, where things are a little bit less sophisticated. So from thinking about how we understand assets and how we use them in the future and do the things we want to do with them, can we learn some stuff from the automotive industry and elsewhere that actually helps us take the process sector down to level 5? And what I'm going to talk about in the next 15 minutes is a tale of how that might be possible. So what does our vision look like? what do we want to do in the future? What does our process plant look like? Well, what I think we want to try and do is get towards an operator specified destination. So if we're thinking about cars again, and we don't input all the different parameters we need into a Tesla or something similar, we put where we want to go and it takes us there. So how do we do that for the process sector? What does that mean? Well, for us, it's not just about asset integrity. It's about cost. It's about OEE. And we might want to specify, actually, I care about the quality of the product for the next X period, because actually that's the most important parameter right now. Or I care about looking after my asset most because actually I've got some concerns that it might not work properly. Or I care about minimizing operational expenditure, and cost is key for the next X period. And actually it's a blend of all that stuff. So how do we configure a plan to do that? Well, artificial intelligence is a big bit of it. And I'm going to talk in a minute about what I mean by AI and give you a bit of a backdrop for what that is with some examples of how and why that's useful and why that will be useful in the future. What is AI doing? Well, as we heard a minute ago from Fluvio, and Andy from Wood talked about it this morning as well, using machine learning, artificial intelligence, it's about taking data. And the process sector is data rich. There's lots of data kicking about. So how can we make use of that? And how can we use predictive models, as Fluvio was describing there, to get that data to help us predict what's going to happen in the future? And that doesn't have to be asset based. That can be cost models to predict how operational cost is going to vary, and blending that with engineering models that tell us how things are going to behave over time. So there's a big mix of things in play. Ultimately, we want our plant to do things automatically. We want it to control the valves and do the things it does to operate. And we want all that stuff to feed back. And that's what we want to happen. We want to be able to specify a destination and let the thing take care of itself. And it's all very easy to describe the hypothetical, but how do we do all that? And how do we do it safely? Because we can't, or there's no point in doing it like that if by what we do, it causes detrimental impact to people, the environment, or the assets themselves. So what I'm going to do now is walk through with you a series of topic areas. It's good that we've heard a few things about a few of these already today, and give you some examples of stuff that we can do now, stuff that have been done, stuff that is being done, and that we can readily realize the benefits out of. First thing, digital twins, digital assets. We hear lots and lots of those buzzwords kicking about. What does it mean? What do we do with it? Well, there's more and more operators these days, laser scanning, coming up with visualizations of point clouds of different bits of plant. And we can use that for all sorts of interesting things like doing design work that fits the as-built configuration. But actually, we can do more with that. We can take it and realize it in a completely different way. So modern computing lets us visualize this stuff. So we can take laser scan data and in a matter of hours, render it in virtual worlds. I think we're going to hear a bit more about this type of environment from some other speakers later today. But we can very rapidly get a model version of an asset that we can walk around. We can move around in that environment, all built on as-built geometry. But that's only one bit. That's a visualization of an asset. It doesn't tell us much. What else can we do with it? Well, there's a whole field of natural language processing that comes out of the machine learning environment. And I'll talk a bit more detail about what is machine learning later on. But the process sector is rich in old data. And how do we get meaning out of that data? How do we get an old PDF document that defines the specification of a pipe that was put in 40 years ago? How do we take inspection results that have been written in Word files? Well, there's this method that we can do this stuff with now, and we can infer meaning from it. So machines, rather than just recognizing that it says steel pipe, it can say steel pipe is degrading, steel pipe is fine, and understand what that means and digitize that data for us. And it can do that across thousands and thousands of documents in no time at all. We've also got all the live data. And again, as Fluvio mentioned a minute ago, we've got all that stuff already. So why can't we start bringing this stuff together and embodying it in a digital representation of both the asset from our laser scan data and actually all the old information that we've got knocking around from every day that's gone in the past and what's happening right now. And we can start to use our virtual environment to look for things like, well, if I know that I want to look at all pipes that haven't been inspected for the last 6 months and are lagged and operating at a point where CUI is in play, very rapidly get the virtual world to show me where they are, represents what I would see when I go out to plant, and then go and look at them. And that's how we can start to use more and more data to understand what's going on. Remote monitoring, we heard this morning about some non-invasive inspection techniques. There's lots and lots of stuff we can do with monitoring things. And I've picked just one example of future trends and how we can use remote monitoring through video to do things in a different way, and how we can look after our assets in a different way than we have previously. So you won't be able to tell, but it's actually a video that's playing at the moment. Very, very, very slight reflective changes in the bottom, but ultimately everything looks static. Modern inspection techniques actually allow us to do more with this, and we can amplify sub-pixel movements through appropriate methods to amplify exactly what is moving, and crucially amplify what is moving and the reasons and then why. So we can look at the resonant frequencies of different parts within that system purely by pointing a camera at something. And this is technology that was first researched for some defense technology, where you were looking at the vibrations of crisp packets through windows and being able to pick up sub-pixel movements in that crisp packet and reconstruct audio from it. We can do the same thing in the process sector right now, and this is done quite regularly, in fact. But how do we take what this means? How do we take how these systems are behaving in real time and feed them into predictive life models? So we could say, well, this system, as it's operating now, is feeding into an asset model that is telling us how long that asset is going to maintain itself for. And that takes us into our world of predictive models. And as I said, Fluvio talked about this a minute ago, but we can do this stuff. We can predict the future right now. We can predict the future from a cost perspective. We can model that and understand the impact of what our plant is doing on our long-term cost of operation. We can take it, we can predict what assets are doing. We can predict fatigue life. We can predict how temperature creep's going to come into it, all based on data we've got right now. What does it look like? Well, this is an example of a rotating machine from the gas turbine industry. This has got 15,000 simultaneously connected GTs, and these are big industrial GTs the size of your house. They're big units. But we can do predictive analytics, predict what's going to happen in the future, predictive life estimations now, so that we can understand how maintenance costs are going to change. We can understand when we're going to have to maintain things, reduce spare lives, extend the life of assets. And it's all accessible right now. So I've mentioned a couple of times AI and ML, artificial intelligence and machine learning. I want to spend just a minute or two talking about what that is, because everyone talks about it and nobody ever frames it really with a what is it and why is it important. And then I'll give you an example of how that can be applied in the context of assets. So what is AI? What is artificial intelligence? Well, the simple answer is there is no answer. So nobody has come up with an agreed definition of what AI is, but there are many interpretations and most of them roughly align. What I define it as is turning data into experience and then taking experience and turning that into value. So imagine you've got a particular bit of plant and you're setting a condition that if the pressure in the system is X, do this, if it's Y, do that. But what AI is about helping the computer, the machine, to understand what happens if the pressure is Z. What if it's something that we haven't seen before? How do you behave? How do you do things to make sure that you're doing the things that you should be doing? And it's enabling the machine to implement that value that the field of AI is all about. So how does machine learning differ? What is machine learning? Well, machine learning is effectively the current way of achieving AI. It's not the only way, but it's the most common way. And it's all about finding patterns in data to achieve a specific end objective. So we can look for, very simply looking at drawing a line through a piece of data and getting the machine to iterate until it finds the best pattern match. But there's many, many other ways of doing the same thing where you've got very complex data sets. In the case of the process industry, there's decades worth of data knocking about, and there's even longer than that amounts of experience locked away in people's heads. So what machine learning allows us to do is to take data and experience and allow computers to figure out marginal gains, etc., that can be realized that a human never would be able to do. So spot patterns, spot trends that mean that doing this thing A means this thing B results. I've been able to do that incredibly quickly to really optimize how assets are being used and how we're getting the most benefit out of those assets. To give you an example of the sort of things we can do with this, this video hopefully is playing okay, but shows some people playing basketball. And we've used some machine learning videos on this particular bit of video footage to understand how people are moving. So the machine is able to recognize where people are, it's able to recognize where their limbs are, it's able to apportion exactly where those assets, in this case our basketball players, are within that image and track them as they move around. So you imagine taking some of the technology we saw of our pipes vibrating a minute ago with our amplified motion and then applying this kind of technology to it. You're very close to having what we would normally think about as a finite element model just off the shelf by looking at something and applying some clever machine learning to it. So it's all there, it's all accessible, but we've not really joined it up in that way in any industries really. But it's the sort of trajectory that I think the industry is going to head down. So we've seen some videos, we've seen some interesting stuff, but so what? The most important thing is, how do we do this safely? How can we combine these different things together and do it in a way that means this thing is going to operate safely? Fundamentally, there's a nervousness associated with artificial intelligence. You don't just want to let a computer loose and go and do things that you don't want it to do. And the most common way we tend to think about how to constrain this, and is how is applied cross-industry, is the concept of AI in a box. So we're going to take our artificial intelligence and put it in a box. And what we're then going to do is take our functional safety standards that define how we can safely operate a particular piece of plant, and we're going to constrain that as another box. And we're effectively bounding the range in which we're giving the AI power to make decisions. So we can set limits, we can set rates, etc., that stop the system from doing things we don't want it to be able to do, or taking our plant into a position where it's doing things we don't want it to. And on day one, that's quite tightly bound. But as trust starts to grow, our boundaries start to shift because we learn more about the system. It learns more about the system. And slowly but surely, we can expand that knowledge and give the system more trust. And that's a fairly typical journey through the introduction of automation and intelligence in industry. To give you an example of how that actually looks, go back to our automotive example. So this is just a piece of footage from America, as you can see here, of someone sat at a junction, and we're in an autonomous car here. And what we've done is we've just applied some person detection algorithms to it so we can see where people are. In a minute, the lights are going to turn green, and the car will obviously recognize from its autonomy rules that means it can go. So it's going to pull away, but as it does so, there are still people on the crossing around the corner. And our safety limits in this instance have been put in place to stop us running over a person. So the car stops, allows the people to move, and continues on its way. And it's a blend of using automation and autonomy with setting the right boundaries and limits that allows us to be able to undertake this. There's an interesting angle here about how far do we need to go with an autonomous system safety versus a human. So if I was driving this car, nobody would have a problem with this because I can drive a car and I understand what safety means and I wouldn't run people over. But what level of proof do we need to provide when autonomy is doing that to prove to people that it's working safely? Is it the equivalent level or is it higher? It's probably a bit more. So before I wrap up my last couple of slides, there are a few however moments in this, and things don't always go to plan. You think about Tesla or another automation in the automotive industry, there have been accidents, things have gone wrong, there have been teething troubles, those sort of things have happened. The Boeing 737 MAX has been grounded for the last 20 months because of a flaw in the control logic, which had a very significant safety impact and caused the plane to pitch into the ground. And this stuff is happening, but other industries have been on that journey. People have learned those lessons. The process industry can pick up and make use of all that learning in the context of how to safely operate a plant. In both these examples, the environment is very, very, very changeable and dynamic. In reality, the process sector environment is a bit more static. We're in roughly the same place. The plant doesn't take off and fly around every day, but the conditions within it change. So it's a challenge, but it's not unachievable. So what have we learned? Well, firstly, wait for my slides to catch up. So the first thing I'd say is getting an understanding of what a plant is and what it looks like and getting meaning out of really static old data, combining it with real-time data has never been easier than it is right now. We can get those visualizations. We can enable people to see it and do things with their assets quicker, smarter, better. We can also use modern inspection techniques to understand and predict and model exactly how assets are behaving without even touching them. There's obviously a need to do invasive testing as well, but this is about how can we do things better and smarter. We can take that real-time asset performance, predict the future, predict the cost, predict the asset maintenance, etc., and then wrap all that together with some closed-loop intelligence. And by stringing all those things together, we get a really powerful perspective on how we might move forward. My final slide, let's revisit where we started. We said the process industry was at level 1 to 3. How do we take the process sector and maintaining its assets down to level 4 and 5 in the autonomy? Well, the answer is you might not want to, which is a little bit controversial, but if you imagine the autonomous car example from earlier, if I take an Archie's car from the 1920s and said, can I please make this into an autonomous vehicle? You can do it, but taking something really old and trying to turn it into something fully modern comes with a huge amount of cost and implications and the kind of effort to drive that through. You can do all sorts of automation on old assets and to help you do things, but actually sometimes it's better to build from the ground up. So as we think about Industry 4, yes, we'll be looking at level 4, level 5 automation in process with the new process plant of the future potentially, but it's not necessarily always the best decision to take old assets and try to circumnavigate and apply level 4, level 5 automation to them. You need to weigh up the benefits, you need to weigh up the costs, and it's thinking about what the costs and benefits are with legacy assets that's really going to help move you into that level of automation and autonomy and understanding how to manage your assets through life. And that's it from me today. I hope that was an interesting run through and made sense to everyone.
Yeah.
Just about on my 20 minutes there, Felix.
Absolutely fantastic. Wonderful. And extremely important, particularly around very honest presentation, I thought, from Chris there about you don't have to do something just because technology is around if it's not appropriate. I always remember a very large company who's involved in this. They're not a member of NEPIC, but they're a huge company, so I'm not going to say who they are. But they did a presentation to several companies from Wilton about we can do this, we can do that. And they couldn't understand why nobody would take it up. And the reason was that all people thought was, this is going to cost me a fortune. Where's my payback case on an aging asset? You know, you can't just do stuff because the stuff's there. I thought it was really important. But also, that doesn't mean you just say, it's all too difficult, we're not going to do anything. Yeah. But yeah, thank you very much, Chris. And Chris will be around later. And if you have any questions, and we'll now move over to Paul Shelton for yet another insight, but again, complementary to what we've had so far. Thank you very much.
Thanks, everyone.